What do file systems HTML and graphical user interfaces have in common? They all use tree-like structures. Each of these systems comprises leaves and composite elements, enabling the nesting of more elements. Have you ever wondered how to implement such a structure efficiently? How can you do it intelligently without reinventing the wheel? Here comes the Composite Design Pattern. This structural design pattern enables the composition of objects into tree structures to depict hierarchies. It offers a unified interface for both individual objects and their combined forms. The UML diagram illustrates the following. This design pattern comprises three main elements: the component interface and two concrete classes, leaf and composite. While both classes implement a common operation, only the composite class has additional methods for adding, removing, and retrieving children. This distinction exists because only the composite class can contain other objects within it, hence the name, composite. Each component can have zero or multiple children, but always just one parent. Without further ado, let's take a look at the HTML example. In the main method, there are two types of objects corresponding to a tree structure: composite nodes and leaf nodes. Composite nodes can contain other nodes within them. For instance, in HTML, the HTML and body tags are examples of such elements. On the other hand, leaf nodes like the img and input tags don't hold other elements inside them. As you've probably noticed, the display function takes an int level parameter. You might wonder, what's its purpose? Well, it's crucial for our pretty print formatting. This parameter helps determine the indentation level for each tag, making our HTML output more readable. When we go deeper into the nested structure, level increases, and with it, the indentation. So, when you see display 0, it indicates that our HTML tag is at the topmost level with no preceding indentation. As we delve deeper into the tree, this number increments to adjust the spacing, allowing for a clearer visual representation of the hierarchy. Both composite and leaf nodes implement a shared interface. This interface's primary goal is to ensure that both individual elements and their groupings are treated uniformly. In our scenario, we use a display method to print elements to the system console. To enhance readability, we've introduced a helper method named indent that prepends white space to the start of each tag. Since composite nodes can contain other nodes, it's essential to maintain a list of these inner nodes. To manage this list effectively, we've provided methods for adding and removing elements. We can effortlessly adapt this pattern to a file system scenario. We just need to make some adjustments to the display implementations and the objects within the main method. You can clone both examples from my GitHub account. The composite pattern is a powerful tool in a developer's arsenal, allowing for flexibility and easier management of hierarchical structures. I encourage you to play around with the code, make your variations, and see how it can fit into your projects. Have you used the composite pattern in any of your projects? Share your experiences below.